Okay, so in this one here, 3-2, it's asking you to see which one's the longest and to draw diagrams. I wouldn't ask you to do that. This one here is a really challenging problem that takes up a lot of time, and that I don't think that the value is really there for what it is that we're looking at. But it is looking at the fact of how we add these together can change each value. Each one of these is a different value, but we'll experience that more in later problems. So I'm going to focus instead on 3-3. It says the expression 5 plus 3 groups of 4 plus 2 can be used to represent the group of integer tiles at right. So the first part of this is where we're going to be explaining how each part of this expression connects with each group of the integer tiles. Lastly, how many tiles are on there. So the first thing that I'm going to do is, on my paper, is that I'm going to draw this diagram right here. So I'm going to go ahead and pause right here, and I will let you pause as well. And I want you to draw this on your paper, please. Okay, so now that you have that drawn on your paper, hopefully you took advantage of that as well. Now we're going to connect this expression with each of the parts in the diagram you just drew. And so what I'm going to do is I'm going to come over here to my paper, and again, I just drew that really quick so that we would have this. And so we're going to connect it to the different parts of 5 plus 3 groups of 4 plus 2. So the first thing I need to do is I need to find these different parts in these representations here in the integer tiles. So most students will see that this right here is my 5. Most students can also see that this right here is our 2. This one, sometimes students get a little, it might be a little tricky about that, but we have 3 groups of 4. And I can see that because I have 1 group of 4 right here, 2 groups of 4, 3 groups of 4. Usually my groups run horizontally like that. Okay? So that is the connection between those two right there.